That's the end of core 2. Parsy, but wait, do we have to do
Differentiation. Chapter 9,
yeah.
yeah. So we've got all of that to do, so we're going to have to rub this off and work for a little bit before cake.
Before cake. Oh. So, differentiation.
Yes.
Let's do it.
Did it at core 1, there's only a little bit of advancement now, it's not hard.
But so you know what it is, just a reminder.
Yep.
What is differentiation?
Well, if you have dy by dx of something like 3x squared plus 2x.
Like that.
You times the coefficient by the power, then reduce the power by 1.
Yeah. So it becomes 6x
Plus
2.
And that's for finding out the gradient. If you know
is.
a value of x at a point on a curve, you can find out a gradient of a tangent to that point.
You can.
A reminder of differentiation.
Gets a bit more tricky at core 2.
Yep.
You could
But
have
not
something
ridiculous.
Like, no, not mad. You just have to have a bit more of a knowledge of indices, which you do, which is handy.
Something
So,
like 1 over
yeah,
x.
1 over x. Yeah.
X to the what?
2.
2. You've got to recognise what that means, because you can't do what you might do if you hadn't learnt this. Times it by 2, which would times the 1 by 2, so it would be 2 over x.
Yeah.
That's not the same as what you do.
No.
You've got to realise that to get 1 over x squared is the same as writing
X to the minus 2. Remember that flips it. And then you can do it.
So that would be minus 2x, reduce the power by 1.
Yep, makes it minus 3.
So as you can see, that isn't the same as 2 over x if you did it that way.
No.
It does get a little bit harder than that, but it's the same idea.
Yeah.
So
if we have another example,
yep.
dy by dx of
1 plus x over x squared or something, I don't know.
yeah, that looks more awkward. Okay.
First you got to break up this division, so it would be 1 over x squared plus
1
x over x squared.
X over x squared was just...
We'll write that intermediate step out first.
Yeah,
I
I think we
think.
should just... So it becomes 1 over x squared
Plus x over x
over x squared.
1 over x squared we've actually just done.
We have just done. So that
X
becomes
minus 2.
x minus 2. And then...
That's x to the 1 divided by x to the 2. And you
Rules
should
of
know from
indices,
your
we
rules.
take them away.
So that's x to the
X and
minus
minus
1.
1. And then we get the differentiate bit.
Yep, I'll do it in blue.
Okay.
Times it by the power and reduce it by 1.
So that's what we did just up there. So first part becomes minus 2x cubed, so minus 3.
Minus 3.
And then the other part,
Minus 1.
Yeah.
Minus x
x minus 2.
That's about as hard as it gets with differentiation.
It is. Yeah.
That's differentiation done.
That's differentiation done. Then have a question we get to test yourself, but until then,
Yeah, let's go on to
let's
integration.
integrate. Integration.
Yes. And then on to the Trapezium rule.
Yeah, which is using integration when it's awkward.
Integration, we'll go through an example much
Yeah.
like we did in differentiation.
Yeah, like from core 1, a bit of a refresher.
So
Like before we have the special s.
x cubed plus x squared, so you're integrating that.
Yep, where you add 1 to the power and divide by it.
Yep, so you
So
get
a quarter of x to the 4 and a third of x to the 3.
plus c.
Plus c, yeah, something you don't know.
Only gets a little bit harder here.
Yeah, like before, you just add more into c knowledge.
Yes, so
So if you find it 1 over x to the 4, yeah, these minus instead.
you need to know that x to the minus 4,
And then you can add 1 to the power, makes it 3.
so minus a third x to the minus 3. That's the same as minus x to the minus 3 over 3. I prefer to write it like that.
Yeah.
Plus c.
Let's see.
Doesn't really get much harder than that, it's just bringing
It
in
doesn't.
indice knowledge.
What it does do is use the Trapezium rule.
Yes.
And that's humongous.
Yes, some things, as far as we're concerned at AS level, can't be integrated by our own knowledge.
No.
So we use the Trapezium rule to find an approximate value for the remembering
estimate.
integration finds the area of the curve.
Yes.
So that's what the Trapezium rule is for, so let's crack on with that.
So let's use it.
Now it's on page 8 of your formula
Yeah.
booklet. First I think I'll read you the question, you can write it up, because we have a nice worked example to go through.
Alright, let's do it.
Alright. So, you ready?
Yeah.
Worked example says use the trapezium rule with 6 ordinates to calculate an approximation. 6 ordinate, an approximation to 5 strips, adding extra detail, we need that.
Yeah.
Integration sign, 3 at the top, 0.5 at the bottom, and it's 12 over x. And then it says, stating with a reason whether your result is an overestimate or an underestimate. But we'll do that when we come to it.
Yeah.
Okay.
Right.
First.
So, the first step should be to write the Trapezium rule out.
Yeah, I think that would be. It's in page 8 of your formula booklet.
We'll get in the exam. You don't need to memorise it off by heart, but practice you probably will do.
Yeah, and I've practised, unfortunately, I know it off by heart. So,
Yeah, okay.
a half h squiggly bracket indicating you do everything within it first. So bracket y0 plus yn, close bracket, plus 2 lots of y1 plus y2 up to yn minus 1. N minus 1. Yeah, close squiggly bracket, where h is b minus a over n. And then it follows that up with the S sign with B at the top and A at the bottom, just to indicate what you're doing in the exam, which is really friendly, in case you forget.
Yeah, so that's the Trapezium rule, and I think we should draw a little graph.
Always a good start is to draw the graph of y equals 12 over x, in which case, in this question, it's actually drawn it for you, indicating in the exam, it would probably draw this one for you.
Probably.
And it looks something like this.
Oh, goodness me. Yeah,
So
that's all of something over x graphs will do.
yes, they always look like that, but 6 ordinates, 5 strips.
Yeah. You need to know what each of these things mean. You know what B and A means, they're shown. N, however,
is the number of strips.
Yes, not the number of ordinates.
If you give it the number of ordinates, you can throw your answer off by quite a lot.
Quite a lot, yeah.
So, it goes from the points 0.5 to 3.
Yep, so
And there's 5 strips in the middle. So, the end of that curve will be 0.5. The other end of the curve will be 3. You divide that up into 1 strip, 2 strip, 3 strip, 4 strip, 5 strip. You don't have to draw another line, because that's 1, 2, 3, 4, 5. 6 ordinates means 6 points down the bottom, 6 coordinates essentially. They go up evenly, so they'll go up in 0.5s in this case. So that'll be 1, that'll be 1.5, 2 and 2.5. Okay? So you just divide it up evenly across the bottom, they have even spacing.
Yep.
Right, so
and now we're going to get on here doing the actual question.
Yes.
Right.
Green, you got green? Okay,
Right, we can do whatever you like. Okay.
So, we'll work out h first,
Yep.
despite doing the timesing bit last.
Yeah, it's good to work out what it is first. So,
B is 3.
it is.
Minus a half is 2.5. And that's over n. N is the number of strips, not the number of ordinates. So n is 5 in this case.
Which makes this equal to
a half. Then you have a half times a half, so outside here we actually have a quarter. We'll get to that when it comes to
when it comes.
So I'm not going to do that now, so that's the last step. I'm just going to do the squiggly brackets to indicate where we are.
Right, so, right beginning, y0. Now what's that mean?
Well, that's the 0th ordinate. It's the first ordinate you come to, and it isn't always 0.
No, sometimes it is, which is quite nice, but yeah it's 0.5.
So you then substitute that into this, where the x value is 0.5.
Yep, and that would make it 24.
12 over 0.5 is 24.
And then we have ym, which is our last one, which is 3.
12 over 3 is 4.
It is.
That's the first bracket.
Then we add it to 2 lots of all the rest of our ordinates.
So if 0.5 is y0, 1 must be y1 in this case.
Yep, and that makes
12
that
for 1 is 12.
12. Plus the next one, which is 1.5, which would be 8.
Yes.
2, which would be 6. 2.5.
I'll do it in the calculator. It's something around 2, 3, 4 point something. 12 divided by 2.5. 4.8.
4.8.
4.8. Right?
Yeah, and that's
Close squiggly bracket.
Because that's all of them.
Right.
And
first I'm going to do
first we should do each bracket. So 24 plus 4, 28.
plus
A-level maths knowledge. Then we do all of this in the graph inside of things
Added.
before we times it by 2.
yes.
So 12 plus 8 is 20, plus 6 is 26, plus 4.8 is 30.8.
6 plus 4.8 times by 2 is, oh, you know it, but
Yeah,
61.6.
61.6.
Now we add them together, and now we can finally
Yeah,
times by
now we
8.
can do
Well,
by a
half
quarter.
inch. Yeah, so a quarter. You got a quarter lots of
Those joined together, which is
89.6.
yeah,
So 89.6 over 4,
and that is
22.4.
22.4. Yeah. So that becomes our answer.
Now
But
that wasn't all of the question.
it wasn't. You had to say whether or not this would be accurate, whether higher or lower than the actual value.
Yes. Now, what the trapezium rule's actually doing, which you need to appreciate.
Yeah, it's finding the area. Well, between each strip.
So
yeah,
it doesn't do the curve, it does.
It does loads of trapeziums because that's what it is.
Now, because the curve goes in this shape, and the trapeziums, when you do a straight line, will be above it.
Yeah, that means it'll be an overestimate.
So I'll put that as a final marking point. Over estimate.
This didn't take that long. That's why you should practice the trapezium rule, because if you don't, it might take quite a long time in the exam.
Yeah.
But once you get it down, it's pretty fast.
The only tricky part, really, is I think knowing what the ordinates and strips means, and hence.
Yes, that's the only bit that people get tripped up at. But N is definitely strips. You need to remember that.
Yep.
Yeah,
Overestimate.
and that's it. So
That's it. We can test yourself. if
test
you
yourself a
want.
question. Yeah.
Let's do it.
Alright, let's do that. Alright, test yourself questions.
Yes, test yourself, page 125, question 3 of this book.
Right to the end.
I know.
125, and that's very
Really close to the end. Yeah.
Very close.
That's exciting. Let's get on with the question.
Let's do it. Okay, it's got quite a lot of quite parts, this question.
Yep, I'll start right over this side.
Good plan. It says the curve with equation y equals 2x plus 27 over x squared take away 7 is defined for x is greater than 0 and is sketched on the right. Like that. Yes. And part A says, part 1, it says find dy by dx. We'll do that.
Okay.
Differentiate it. I think we can handle that.
Yep, the only hard bit, and it's not really that hard.
No, but we
is
mentioned
what
before.
that is.
Yes.
1 over x squared is x to the minus 2.
So
27 lots
over.
of that would be there.
Yeah, it's just 27 over x and x over x
So
to
that
minus
makes
2.
that 2x plus 27 lots of x to the minus 2 minus 7.
Absolutely.
We differentiate that. You times it, then reduce the power.
Yes.
It's going to
so
be 2 plus, or maybe minus, because you've got to times that by minus, so it's
Yeah,
going to be
so
minus 54 x,
x
reduce
minus
the
3.
power. Yeah, minus 7. Minus 7 disappears because there's an x to the 0 here.
It does, so,
Times
it's
by
just,
0 it
so
goes.
that's just gone. That's part 1.
That's part 1.
So part 2
Yep.
is
ready.
the curve has a minimum point m.
M.
Find the x coordinate of m.
Okay.
So minimum
When-
points.
When it has a minimum point, it equals 0 when the
Yeah.
correct x value is placed. So
Yeah,
that makes that equal to 0.
that's something from core we didn't go over earlier, but you should remember, and hopefully this reminds you. So now I think we should move the 54 over.
That makes sense. You don't want to negative anything really.
Yeah.
X to the minus 3 equals 2. It's been taken over, but I've then swapped it.
Yeah.
Sensible would be to put it sort of back into that form, except
Yeah.
it wouldn't equal that.
So
that'll
it'll be
be
54 over x cubed.
X cubed equals 2. 54 over 2 equals x cubed.
Yeah.
54 over 2, 27. Which is good because we know the cube root of that is 3. It should be one of the ones you're familiar with.
Should be. That's that.
That's that. That is the minimum value.
Excellent.
The only hard part is noticing that that has to equal 0, but that's core 1.
That's cool one. So you should remember that. And then it's on to the integration part.
I think we should swap
I
sides.
think we should. So it says find the integral of 2x plus, well, let's walk the integral of up. What we did
I'm
before.
just going to skip that step, then I'm going to put it straight in the form that we worked out there.
Okay, so in which case find the integral of 2x plus 27x to the minus 2, take away 7 dx.
So integrate.
Yes.
Okay?
Yep.
Add 1 to the power and divide by it. That would go to x squared 2 over 2 is 1.
Yeah.
X squared.
Then that one with
And
minus
that will be minus 27.
Yeah.
X to the minus 3. Like I said, there's an x to the 0 there, that's now up to x to the 1.
It is.
Minus 7x.
And then plus C, something we don't know. It could have been lost by differentiating.
That's part 1, so we've got part 2 now.
And part 2 is, hence determine the area of the region bounded by the curve, the lines x equals 1 and x equals 2. So that means there's 2 at the top of RS and 1 at the bottom.
Yes. So we
should remember from core 1 that we do that, and we take away, put that in there, and take that away from 1.
Yep, so x is now 2 for the first bracket.
Yeah.
2 squared is
4. Take away 27 lots of 2 cubed, or minus 3.
The minus 3, that's 1 over 8, isn't it?
Yeah.
That's 27 over 8. Minus 27 over 8, what's that? Minus 27 over 8.
Okay. Got a calculator.
Yeah, what is it? Wait, that's not minus 3, that's minus 2.
No, it's minus 2.
So what is that?
It's 13.5.
13.5.
Yeah.
Excellent. 13.5 minus 7, lots of 2, which is minus 14. Minus.
And one lot of it.
So
1
minus 27. Because 1 over 1.
Yeah, and then minus 7.
Minus 7.
So we should do these in 2 steps.
Okay, so first bracket is...
So it's 4 minus 13.5 minus 14, which is minus 23.5. The other half is minus 33.
So that becomes
A plus.
minus 23.5 plus 33, which is 3...
It is
9.5?
It is 9.5.
Alright. And that's it, is it?
And that's the answer. Yeah, that's all of our test set questions. We would do a
trapezium rule
that's
question.
what I was looking for, trapezium rule question. But
we just did one a
we just
second
did
ago,
one,
we don't
so
really want to do a
don't
whole
do
another one. Step aside, you can see the answers.
yeah, that's why we did that. Yeah,
As
summary
usual,
time.
yeah, but as usual, it's in a proper exam question.
Oh, of course, yes, from 2002.
I think so, yeah.
Yeah.
So it could come up. So
Could
yeah,
come up.
summary time, Trapezium.
Alright.
Crack on. Okay.
Hello. Summary of the last chapter
Yeah,
in Core 2.
we thought let's not sit down, let's observe.
Let's observe all the wonders that we'd gone through. Most of them.
That's a lot of the major things you need to know.
They are in the Formula Book Club, but you know how to use them, and that's the cool thing.
Yeah. So,
So
if you don't recognise any of them, have a look at our site.
we've got to go back to our videos.
We actually go through all of these things individually.
We do.
Anyway.
Yes. Well, on to the summary of what we just did. Yeah.
Differentiation first.
Yeah, we did. Just reminding what it was like.
And then
What you do.
a little bit of advancement.
Yeah.
Not much for
Not much
differentiation. You can't do much.
No, but basically, you take one from the power and times by that.
Times by that.
Yeah.
Then integration, again, remind you of what we did at core 1.
Yeah, pretty much the reverse.
Yep, so add 1 to the power, divide by it.
Yep, and let's see at the end.
Yeah.
Yeah.
That led us into the trapezium rule.
We actually use stuff.
Trapezium rule is a substitute
Yeah.
for integration.
When you can't do it for whatever reason, if it's a very strangely shaped curve. Yeah, and then it's an estimate. You just say if it's above what you think it is or below. And that'll do the way it's curved.
Another way to make it more accurate is to have more strips.
Yeah.
Because if they're closer together, then the line above at the trapezium is closer to being a curve.
Yeah.
That might be a marking point.
Might be a marking point. Obviously don't want a million strips because that'll take a million years.
Yeah. And then we did a test yourself as usual from an actual paper.
Yeah, and as usual, all actual papers. If there's a question you're struggling with, send it to us on Facebook. Clever Cracker Squared, all those words.
Yeah.
And we'll answer it.
Yeah?
Yeah.
But core 2 is over, Trick.
It is, and it's actually I think the nicest maths exam you're going to do in AS. Enjoy it.
Yeah, core 1's nice because it's easy. This is nice because it's real maths.
Yeah, and
It's
stats
nice.
is...
Stats is horrible.
Stats is stats, no I like stats.
But,
Yes.
it's been Wayne Leck
James Trevette.
in core 2.
We are Clever Cracker Squared. Checking out.
Check it out.
Alright.